So continuing our exploration of the world of functions, we're going to now look at a specific kind of function, the one-to-one function. And so what a one-to-one function is it basically it can only, so there's only one x value for one individual y value. So you can't have the same y value for two different x values. So for example, y equals x is a one-to-one function, and y equals x squared plus some constant is not going to be a one-to-one function because, well, there are two same y values for two different x values, so it's not going to be a one-to-one. And so when we test for one-to-one functions, you can see we're using a horizontal line, and that's why when we test to see if a function is one-to-one, we call that a horizontal line test. And so if you remember, it's kind of like a vertical line test for functions, but we have the horizontal line test to see if a function is one-to-one. So that's the horizontal line test. And so why do we need to find whether or not a function is one-to-one? Well, it turns out that this is actually important to determine if a function has, well, an inverse. And so we're going to talk about that in just a little bit. But yeah, so this horizontal line test will test if the function has multiple y's that are equivalent for different x's. And so the condition that we're meeting here has to deal with inverse functions. And so one-to-one functions, well, if a function is one-to-one, it can have an inverse function. And so that's why we want to find if functions are one-to-one, because inverse functions are of the form f negative 1 to the x, and that's not negative 1 power. It's just a notation that we use to denote the inverse, like, of f of x is f negative 1x. And so for an inverse function, you have x and y, right? This is just for a regular f of x function, 0, 1, 2, 3, and then maybe say like 2, 3, 4, 5. But what's going to happen is you're going to switch the x and the y for the inverse function. And so here, actually, you're going to have x and y are going to be switched. So it should actually say in the left column there, it should be x, and the right column should be y. So basically, you're just taking all the x and the y values and switching them for the inverse. And so if you remember from pre-calculus, this actually is kind of an interesting thing that's going to happen, because if we go back to this idea of combining functions and making composite functions, we can see that inverse functions, if we take the composite, will always generate a specific variable. So we see that say f of x and g of x, like before, their inverses, and we take f of g of x. What is that going to be? Well, it's always going to be equal to x. And the same thing is true for g of f of x. That's always going to be equal to x. And that's going to be true for every pair of inverse functions. And remember, this relationship is going to be relatively important when we take derivatives in calculus of inverse functions. So let's look at a specific common pair of inverse functions, just so we have a better understanding of what inverses really are. So say we have y equals log base 10 of x, and we have y equals 10 to the x. Well, these two functions are inverse functions. And that's because what logs really do is they kind of undo powers. So if you have like log base 10 of x and 10 to the x, well, 10 to the log base 10 of x is just going to be equal to x, because these two functions are the inverses of one another. And so log base 10 of 100, for example, is going to be equal to 2, just remember, because of logarithms, and because 10 squared is going to be equal to 100. And so that's kind of another example. We're switching around the x's and the y's for these two functions. And another kind of logarithm that's going to be really important in calculus is the natural logarithm, log base e, except we don't typically write it like that. Instead, we usually call it we call it ln. Natural log, it's kind of a weird way to write it, but because it doesn't really stand, I mean, I guess I don't really know the origin, but this is going to be important later, and you might have already seen it in your pre-calculus classes. But really, this is also important, right, just for the change of base formula, because you have the log base a of x equals the natural log of x over the natural log of a. And that's a good formula to remember because we deal a lot with that in log rules and conversions and such. All right, so finally we're going to talk about trig functions. And so these guys you've probably seen, hopefully you've seen them before, and you know that if we take a right triangle and say we have a right triangle with sides A, B, and C, and we have an angle theta, then the sine of this angle theta is going to be equal to opposite over adjacent, or opposite over hypotenuse, B over C. The cosine of theta is going to be equal to adjacent over hypotenuse, A over C. And the tangent of this angle theta is going to be equal to opposite over adjacent. And so these relationships are good to know, and if you do not know them, I suggest reviewing this video more or just reviewing external material. And we can say there's the sinusoid function family, which is sine and cosine. And yeah, this is kind of a poor graph, but this is kind of what it generally looks like. You've got a wave-like kind of curve here. And you're going to see that on the sinusoid we have an amplitude, and that's going to be the height, the difference essentially between the equilibrium point and the top of one of these little peaks here. And you're also going to have a period, and the period is basically the difference in x between the same y value on the sinusoid graph. And the sinusoid is really just a general form, sine or cosine. And we can also graph a tangent function that's kind of a general look at a tangent. We have these vertical asymptotes for a tangent. And so we can kind of show them the graph. This is a poor drawing, but you get the idea. I mean, the tangent is essentially it kind of stalls out at the horizontal, and then it rapidly grows after that toward the vertical asymptote. And so there are three other trig functions that you should know, and those are secant, cosecant, and cotangent. And so these are really just the reciprocals of our basic trig functions that we already know. So secant is 1 over cosine, cosecant is 1 over sine, and cotangent is going to be 1 over tangent of x, or cosine of x over sine of x. And so that's really that just like the very basic trig function stuff that you should know before going into calculus. And just a good thing to remember also, this is going to come up later when we're dealing with series, the cosine of x is an even function, and sine of x is an odd function, and you're going to see why, and it's pretty cool. When you get to the end of the year, your teacher should tell you why this is true, and it will blow your mind, hopefully. But yeah, that really is, hopefully, I think we've covered all the bases there, very basic stuff to review. Thank you for watching this video. I hope you enjoy.